anatomy video where we are going to describe the anatomy of the bones which we can see in the antebrachium region. So we mean here the radius and the ulna. So, and after that, of course, we will look at the comparative anatomy between the different animal species. So let's get started. So here we have the radius and ulna of the horse, as you can see here. And after that, we will talk about the comparative anatomy as we said before. So the ulna, this is the ulna, this is the radius. So they are fused together in the horse, not completely, of course, and that's why they form together here. There is a space between the ulna and the radius called the interosseus space. Interosseous space. So here we have the radius, and here we have the ulna. The ulna in general is located. This is the caudal view. This is a caudal view, and the ulna is located caudolaterally. So caudolaterally here in this area. So the radius and ulna here in the proximal part, they form together the articulation surface. This is the articulation surface of the radius and ulna for the articulation with the humerus or with the trochlea of the humerus in this way here. So let's go directly and talk about the radius. So the radius is a long bone. That means, as we know, so it has a proximal extremity and distal extremity and body in the middle or shaft. If you look at the shaft here is a little bit, flattened with two surfaces. So here we have the cranial surface and the caudal surface. The cranial surface is smooth without any projections, as you can see here, and is slightly convex comparing to the caudal surface, which is slightly concave. So it's very easy to identify where or which one is the caudal surface and which one is the cranial surface in the horse here. If we move to the proximal extremity of the radius here, we can see again here the articulation surfaces. So two condyles for the articulation with the trochlea of the humerus. Between these two articular surfaces here we can see a sagittal ridge here, sagittal ridge, and if you look exactly we will find that the medial articular surface is slightly bigger than that one of the lateral side. And as we described before, these two condyles plus the articular surface of the ulna, which called here the trochlear notch, so they are there to form the articulation surface with the trochlea. So this is the trochlea of the humerus, and they form these three bones. Three bones they form together the elbow joint. The elbow joint. Good. So let's go back to the proximal extremity of the radius. So in the cranial view here we can see two tuberosities or projections, medially and laterally, called this is the lateral tuberosity, this is the medial tuberosity. They are there for ligament attachment. In the cranial view here we can see this big rough surface called the radial tuberosity, and here in the case of the horse we can see how the radial tuberosity is connected to the medial tuberosity, and that's not the case for example in some other animals. So we will talk about the comparative anatomy later. Good. If we move now to the distal part of the radius, so distal part of the radius here in the cranial view here distally we can see depressions or grooves. This is the area where the tendons of the extensor muscles move through, here, there, and this oblique one here. So we name them as extensor grooves. This is the extensor grooves. Here laterally and medially, so this is the lateral and this is the medial side of the bone. So here we have two projections. They call the styloid process. So we have the medial styloid process, and here we have the lateral styloid process. They are also there as a origin for the collateral ligaments from the radius to the carpal bones and finally to the metacarpal bones. So here we have where we can see the ulna here. So if you can see the ulna, we say the ulna is located caudal-laterally. That means this is the caudal surface of the radius. So that means this is the lateral styloid process. This is the lateral styloid process here. On the medial side, we have the medial styloid process. If we move to the caudal view here, we can see a lot of depressions and rough surfaces for muscle attachment. Here, distally, you can see articular surface. Articular surface. This surface is for the articulation with the carpal bones. So we will talk about the carpal bones later. So the carpal bones are organized in two rows. So proximal row and the distal row. And of course, this articular surface is for the articulation with the proximal row of the carpal bones. And if you look exactly here, also we can see that the medial articular surface is slightly bigger than that one of the lateral side. So here, with regards to the radius, where can we find the nutrient foramen? So it's not clear here because the nutrient foramen is located inside here, inside the interosseous space. So if you want to see it, you have to remove the ulna, which is a little bit difficult here, as we said, because they are fused together, the radius and ulna. So if we move now to the ulna is a long bone with the proximal extremity and the distal extremity in this area here. So this is very important here to mention that the ulna or the distal extremity of the ulna doesn't reach the end of the radius in the horse. So in this case we can describe it as a somehow reduced long bone. The proximal extremity of the ulna forms here this big projection called the olecranon. On the olecranon here we have this very big rough surface. The olecranon tuberosity is very developed, and it's the insertion area of several muscles like the anconeus muscle, the triceps brachii, and the tensor muscle of the antebrachial fascia, for example. If we look in the caudal view here, we can see that the olecranon is a little bit flattened. The medial surface of the olecranon here is slightly concave comparing to the lateral surface, which is straight or slightly convex. If we move to the cranial view here, we can see that from the olecranon here we have this projection called the anconeal process. The anconeal process is continuous here with the articular surface of the ulna for the articulation with the trochlea of the humerus, or what's called the trochlear notch. So this is the trochlear notch of the ulna. As we described before, the trochlear notch articulate with the trochlea, and the anconeal process moves during the flexion and extension inside the Olecranon fossa. This is the Olecranon fossa. So inside the Olecranon fossa of the humerus. So here in this view, the cranial view, we can see the borders between the ulna and radius in this area here. So here we have the articular surfaces between the ulna and the radius. And if you look exactly here from the trochlear notch or from the ulna here, we have two projections. So medially we have this one, and laterally we have that one. So this is what's called the coronoid process. So we have the lateral coronoid process, and this is the medial coronoid process. They are clinically extremely important, specifically like in small animals like dogs and cats. There are a lot of clinical cases related to these two projections or coronoid processes. In general, so this is the main anatomical features of the ulna. So let's move now to the body. Is a small body here in the horse, fused to the body of the radius, and as we described before, the distal extremity ends here. Doesn't reach the distal part or extremity or end of the radius in the horse. And now let's move and talk about the comparative anatomy between the different animal species. Okay, as you can see here, we have the radius and ulna of the horse, of the camel, of the ox, sheep, and dog. And let's start with the comparative anatomy. If we compare, let's put this one here to the side just for a minute. If we compare the radius and ulna of the horse and the ox, so here we can see how the radius and ulna, we say that the radius and ulna in the horse, they are fused, and the distal end of the ulna doesn't reach the distal end of the radius, as you can see here. While in the case of the ox, yes, they are somehow fused, but it's firstly the ulna is longer than the radius. Here in this case, the body is very clear, so the body is very clear and reach, as you can see, the distal end of the radius here. In the same way, the ulna has also the olecranon tuberosity. Here we have the anconeal process and the trochlear notch of the ulna. Here we can find actually two interosseous spaces, one in the proximal region here and the other one in the distal region here. So this is the proximal interosseous space and this is the distal interosseous space. The ulna, as you can see here, ends with the lateral styloid process, or we can name it the styloid process of the ulna. Styloid process of the ulna, which is located in the caudal. This is the caudal view. Why it's the caudal view? Because we can see the ulna in front of us, as we said before, located caudal-laterally. So here we have the styloid process of the ulna is on the lateral side, while here we can see the medial styloid formed by the radius. Medial styloid process. So if we look at the body again, it's a slightly convex here cranially, slightly concave caudally in the proximal region here. We have also the articular surface with the trochlea of the humerus, but here it's more clear that the medial articular surface is bigger than the lateral one. Laterally and medially, here we have the medial and lateral tuberosities. Lateral and medial tuberosity. So this is the lateral tuberosity, this is the medial tuberosity. If we compare this one with the horse again, so we can see that the radial tuberosity is more clear in the horse comparing to that small one here of the ox. And at the same time, it looks like the radial tuberosity is not communicating with the medial tuberosity here in the proximal region. So if we move to the distal part here of the radius and ulna and compare that one of the horse with that one of the ox, so in the same way we say that here we can see the extensor grooves. Here we have also extensor grooves. The main difference here, if you look at this view here, we can see that the articular surfaces, they form like grooves here in the horse, which are like straight cranio-caudally, while if you look at that one of the ox, we can see that they are more oblique. So in the caudal view, yes, so here we can see how they are really more oblique comparing to that one of the horse. Here we have very good developed, depressions, as we said before, from muscle attachment. Again, so this is the medial styloid process or the styloid process of the radius. This is the lateral styloid process or the styloid process of the ulna. Okay, so if we move to the sheep, for example, as we always describe, the sheep looks like that one of the ox, while here actually, so that's why we say sheep is a small ox. So here the body of the ulna, the sheep, is more fused and not really distinguished from the body of the radius, but it forms distally the styloid process of the ulna. Okay, here we can see the proximal, so what I can see is the proximal interosseous space, but I cannot find the distal interosseous space if we want to compare this one with the ox. The body here is more flat or flattened, and the same way as the ox. So we can see that here we have the Olecranon, tuberosity, Anconeal process, Trochlear, notch, and so on. Here we have the tuberosity of the radius or radial tuberosity. In the distal part here, it looks exactly like that one of the ox. So the articular surfaces with the proximal row of the carpal bones are slightly, oblique. Good. So if we move to the camel, let's move to the camel. In the camel, as you can see here, it's very interesting. In this case, we can find that the ulna is completely fused with the radius, and that's why the space which we described before as interosseous space, it looks like a foramen, and we will name it here as interosseous foramen. Here in this view, we cannot see any borders between the radius and ulna, so because they are completely fused with each other. Otherwise, here we can also see the Olecranon tuberosity. We have the Anconeal process and the trochlear notch. Okay, so here in the proximal part, of course, more to the medial side, we can see, so if we look here, so this is lateral, this is medial. Medially here we have more like rough surface represents the radial tuberosity. Here we have the lateral and the medial tuberosities for ligaments attachment. If we look at the body of these two bones here, we can see just the body of the radius, so just the body of the radius, while the body of the ulna is completely fused, or it's just somehow inside the body of the radius. But we need to know that if we move distally, here the distal part of the ulna looks again here to form the styloid process of the ulna. Where we can find another interosseous space in this area here. So that means the ulna start here, fused completely. So this is the proximal extremity of the ulna in the camel. The body of the ulna is not there, is completely inside the radius, while here distally, so from the body of the ulna, we have again clearly here the styloid process of the ulna. Good. Here in the distal part, again, we have the extensor grooves, and on the medial surface here, from the radius, we have the styloid process of the radius or the medial styloid process. So, okay. Good. So here, as we said before, because of this fusion, so we cannot see the coronoid processes anymore. There's no coronoid processes, lateral and medial, while it was very clear, of course, In the horse, as we described, these two projections here are the medial and the lateral coronoid processes. The same here in the, for example, in the ox we have the two coronoid processes. Good. Now let's move and talk about the radius and ulna of the dog. In this case, it's like that one of the human, you know, the radius and ulna are completely separated. Not only this, there is a joint between them. There is a joint between them. So here, normally, just a minute, let's put them in the right way. Exactly. So this is the articulation between the radius and ulna, the proximal region. This is how it looks. So in general, the ulna starts proximally here, or located in the proximal region here, caudal to the radius, while distally it moves to the lateral side of the radius. In general, so the ulna is longer than the radius in the dog. So let's start with the radius. So the radius is flattened craniocaudally. Yes, so the cranial surface is convex comparing to the concave caudal surface. Is also somehow smooth without, you know, clear projections. If we move to the proximal side here, we have the articular. So this is very important. In this case, in the dog, we can see that the head, or the proximal extremity is smaller than the distal extremity. So the distal extremity is bigger, and it forms on the medial side the styloid process of the radius, or the medial styloid process. So distal extremity is bigger than the proximal extremity. Here we can see the articular surface with the humerus, with the humeral trochlea, and caudally. So if we have just this part of the radius, you have in the proximal region to look at the articular surface with the ulna, which is located in this case caudally, slightly circumference articular surface for the articulation with the ulna. So there is a slight movement or rotation, so between the radius and ulna in the horse, or in general in carnivores. Okay, so this is the medial surface, this is the lateral surface. Here proximally very small, like radial tuberosity. We have again here the extensor grooves, the articular surface with the proximal row of the carpal bones. Okay, so again let's put them together. Again, this is the caudal view of the radius, and this is the ulna. We have to put it in the way that this area here of the ulna articulates with the head of the radius, like this. As I said before, proximal region here is located caudal to the just like this, just a minute. It was wrong as we started at the beginning. So this is how we put, you know, the radius and ulna. Here this is the articulation surfaces between them, and the distal part of the ulna moves to the lateral side of the radius, like this, and forms here another small facet or articulation between them. So if we look at the ulna now, the ulna has also in the dog has also proximal extremity and distal extremity. The proximal extremity has also like a big projection called the Olecranon tuberosity, which is in the dog somehow divided here, forming a small groove. In the same way, we have a medial concave surface and lateral straight or convex surface here of the Olecranon. We have Anconeal process, trochlear notch, and here again in this case, because the ulna and radius are completely separated, we can see articular surface here for the articulation with the radius. If we move down here, we have the body. This is the body, is more developed here, and the distal end of the ulna represents the styloid process of the ulna, or what's called the lateral styloid process, where we can in this case find a small articular facet here for the articulation with the radius.